Okay, welcome back to part 2 of the population lecture series for the AP Environmental Science classroom. In part 2, what we're going to look at is quantifying population growth. Alright, so in part 1 we talked a lot about some of these concepts about population. Now we're going to try and quantify population growth. The first way that we'll analyze population and changes in population is called the age structure pyramid. Alright, I'm going to give you a quick tutorial or training session on how to read an age structure pyramid. Age structure pyramids are good predictors, right? And that's what they're really good for. And they predict future trends in economics. You'll be able to tell a lot about not only the present state of a population but future trends. And here's how you do it. So now if you notice the age in the center column on the y-axis, and then on the x-axis, on one x-axis we have females, and then on the other x-axis we have males. Okay, and what we're going to do is we're going to classify people according to their age. All right, here's your training. When you look at an age structure pyramid, what you want to train your eyes to see are 3 sections of the graph. Okay, in the first section are people from age 0 to 14. Okay, and we're going to call them pre-reproductive individuals. And then what we're going to do is we're going to section off people between the ages of 15 and 44, and we're going to call those our reproductive. And you can imagine the rest of everybody up here above 44 would be post-reproductive. And if you do that, if you can train your eye to look at these 3 sections of people and look at the distribution of those people, you can see a couple of things. So let's take a look here. Alright, so now in this population here, in the first age structure diagram on the left-hand side, would you say we have a lot of people in the age 0 to 14 range? What you do know is you can compare that to the amount of reproductive, and it seems about the same. Alright, so in this population you have the same amount of reproductive as you do pre-reproductive. So now think about when these pre-reproductive people get to reproductive age. What would you expect for the future? You'd expect the same amount of, again, pre-reproductive people in the next batch. Alright, so what we have here is what's called a stable population. Right, it's stable. There's always about the same amount of reproductive people as pre-reproductive. In post-reproductive, you always have a die-off. Now, the quicker the die-off, it'll tell you a little bit about the living conditions in that population or lack of medicine. And if you don't see any or few older people, that'll also tell you about the living conditions. So, if you take a look at the graph on the right, the age structure pyramid on the right, here we have a greater amount of pre-reproductive than we do reproductive. So what does that tell you about this population? When you have a greater number of pre-reproductive, when they get to reproductive, you're going to have a greater number of pre-reproductive. What you would see here is called a rapidly growing population. There's a lot of people about to reproduce. You would have a rapidly growing population on the age structure pyramid on the right. Let's take a look at a couple more examples because I know that might have been confusing. Here's a couple of examples. The example is Spain, and what we're going to look at is a situation where there's 0 population growth, or ZPG. And a ZPG is a stable population. There's 0% growth. That doesn't mean that it's negative. All right, we're going to see negative in a second with Germany. What that means is there's same amount of reproductive people as pre-reproductive. So when pre-reproductive is ready to reproduce, there'll be the same amount again of the next generation of pre-reproductive people. It's a stable population. All right, the populations are not really growing. All right, Spain, Austria, Greece are examples of populations that really aren't growing. They've reached 0% zero population growth. Let's take a look at Germany. Their age structure pyramid. There's a certain number of reproductive people, but check it out. There's less pre-reproductive people. So when they get to reproduce, there's going to be less offspring. So what we see is with each generation, less and less and less people, and unfortunately, there's more of an elderly generation. So places like Germany, Bulgaria, Sweden, they are experiencing negative population growth where there's more older population. Right, and less younger. That could be a problem. Think about that economically speaking. This generation will have to bear the burden of these people who want to retire. And if there's a lot of them, the reproductive people might not be able to cover those costs, the retirement benefits, the health care, and so forth, which would lead to less people being able to retire. I'll put a little exclamation point here because that could be an economic problem, to have negative population growth. In order to grow economically, you need stability or you need growth, depending on your country and your situation. Okay, so let's take a look at these age structure diagrams and let's analyze the three of them. And what I have here is an age structure diagram. One of them represents Afghanistan, one represents the United States, and one represents Italy. You're going to have to use a little bit of background knowledge and think about what do you know about the population of Afghanistan, United States, and Italy. Let's take a look here. All right, so let's look at right in the middle here. Let's look at the first one in the middle. And we're going to ask ourselves, is it a growing, stable, or decreasing population? All right, so let's take a look at the middle to start. All right, so you have the same amount of, almost very similar amount of pre-reproductive as reproductive. Okay, so you can already think that this is a stable population, and you have a healthy decrease as you get higher. Okay, so that would be a stable population. All right, let's take a look at the leftmost one here. 0 to 14, pre-reproductive. You have lots and lots of pre-reproductive. Reproductive age, not as many. Increase, it gets fewer as you go up, not as many. And then your normal die-off. In fact, it looks to me like there's not too many elderly, which means conditions must be tough in that country. All right, but nevertheless, you have a lot of pre-reproductive, so this is going to be your growing population. Okay, so let's take a look at to the far right now. You have more of a reproductive age structure than a pre-reproductive. These get up here is not going to be as many, so you're going to continue to decrease in population. So now you have a decreasing population represented here on this age structure diagram. Okay, so think about the Afghanistan, United States, and Italy. You could already imagine that the United States is your stable population. All right, we're growing, but we're not growing too fast. Consider us basically stable. All right, then you got Afghanistan and Italy. Italy, if you've seen them in the news, they're having economic hardships at the time, but it's still a country that there's really great cities, there's a great history there. You can almost think that people would live long there. So you have a population that is able to become elderly. Where in Afghanistan, in order to survive, you have to have lots and lots of babies, right? Because some of them are probably going to die. Women might have 5 babies knowing 1 or 2 of them aren't going to make it. So to ensure your family, you're going to have as many as possible. And then conditions are tough the older you get. Afghanistan and Italy. What can you see for the future of Afghanistan? I see a growing population with the next generation having lots of reproductive age people, which is going to produce a lot more offspring. So Afghanistan is in a place in their history where they're growing. All right, the United States is stable, and unfortunately Italy is experiencing this decrease in population, represented by the age structure pyramid. Okay, let's move on here. All right, so in class now we're going to build and analyze an age structure pyramid for our region. We'll be able to take a look at what the age structure looks like and maybe make some predictions for our Souderton area in the classroom. Okay, so it's important that you understand these concepts. So ask some questions in class if you have questions about the age structure diagram and how to read it. Moving right along, continuing to quantify population growth. All right, an important number is the average growth rate. Okay, and that's expressed in a percentage. So what we're going to do is we're going to compare what's called the crude birth rate, and that's the number of births per 1,000 people in a year. And we're going to compare that to the crude death rate, the number of deaths per 1,000 people in a year. And then we can put that into a percentage, and we get what's called the growth rate. So let's take a look at the United States growth rate, okay, the U.S. growth rate. And we're going to call the growth rate R, which is in a percentage. So what we're going to do is we're going to take the crude birth rate, 13, and we're going to subtract the death rate and put that into a percentage. So you can calculate that through and pause the video and see what you get and see if it matches my numbers. Okay? All right, calculate that through. You get 0.47%. All right, that represents the United States growth rate, and actually that number is kind of old at this point. All right, you'll see in the next slide or two that that number is updated as of 2011. With these current numbers here, 13 as a birth rate, 8.27 as a death rate, you get 0.47. So what you see is that we are growing, albeit slowly. And, we talked a lot about exponential growth. If you get a growth rate percentage that is 1 or greater, you have exponential growth. All right, so 0.47 is by no means exponential growth, but it is a positive growth rate. We saw that the United States has somewhat of a stable population. We are growing a little bit, and it's represented here in the United States growth rate, R. Okay, pretty simple calculation. All right, so let's take a little bit of practice here. All right, so here's a table with a couple of countries here, and I've provided the birth rate and the death rate. But what you're going to do is you're going to calculate the growth rate percentage. Okay, so take the birth rate minus the death rate, divide it by 10 to get into a percentage. Pause the video and fill in the 5 missing growth rates. Okay, so after that work, you should have something like 0.66% for the United States. That's a more updated number, probably more accurate to current growth. All right, again, slow growth, not exponential by any means, but slow growth. And then you look at China, 0.67%. All right, again, it's not exponential. China did grow exponentially for a long time, and they had implemented their one-child policy, which we'll talk and learn about. Their one-child policy was effective, right, through providing incentives and family planning opportunities and things like that. They've reduced their growth rate, and it's currently at around 0.67%. But remember, that's slow growth, and they have 1.3 billion people. Okay, so remember that. And now let's take a look at India. Calculate the growth rate through, and you get 1.6%. All right, here we have a situation where exponential growth is occurring. All right, the growth rate percentage is greater than 1. If you're looking at the numbers, 22 births per 1,000 people, only 6 deaths per 1,000 people. They're growing exponentially, and they have 1.2 billion people. So India in the future, in the very near future, is going to surpass China in population. Think about that and about their demand on resources as we move into the future. Take a look at Japan. Calculate it through. We have a negative growth for Japan. A predominantly elderly society, or more deaths than births. Okay, so they have actually a very slow but real negative population. And then we get to Nigeria, and these numbers should have hit you as you calculated them. 41 births. To survive in Nigeria, to ensure your family lineage, you need to have many kids. Having more kids means more beggars in the streets, which means more food for your family. Okay, so to make it in Nigeria, women are having lots and lots of babies, and we calculate their growth rate at 2.5%, which is very, very, very fast. Okay, they're at about 113 million people in Nigeria right now and growing exponentially. So the average growth rate per year is something that you want to look at because you can compare and you can understand the population of that country and what it's doing. So let's take a look at another concept called the rule of 70. We can figure out how long it takes for a population to double using the rule of 70. Very quick and easy calculation. The doubling time only works when the population is growing exponentially. So remember, that's greater than 1% growth rate. Okay, so to do this, what you need to do is take 70, okay, the rule of 70, all right, and divide that by the percentage growth rate, so R. Let me reset my brain here. All right, 70 divided by R, which is in a percentage. Okay, and then that equals the doubling time. But when we do this, the trick is to take everything in decimal form. So what we're going to do is we're going to take 0.7, that's 70% in decimal form. And we're going to take R in decimal form. So let's do the world and see when the world doubling time would be. How many years is it going to take the world population to double? Putting 1.2% into a decimal form, how would you do that? Percent. Don't make the mistake. We want 0.012. Okay, now 1.2% is in decimal form. Okay? Calculate that through, and we can get the years in which world population would double. Okay? And we get 58 years. All right, so if it's 2014, 58 years, in your lifetime, you will see the world population double. 14 billion people. Okay, that's a little scary. All right, we're at 7 billion people, and we're having this discussion of carrying capacity and overconsumption and not enough resources. So think about that. And just for practice, you can calculate Gaza and Rwanda, the doubling time for practice, and then we're going to go back and complete the table in the previous slide. So go ahead and calculate Gaza and Rwanda. 0.7 divided by 0.03. Calculate that through. Gaza is the fastest growing population in the world currently. Okay, calculate Rwanda. All right, and if you know anything about the situation in Rwanda, all right, a lot of refugees, very tough life. 25 years, their population will double. Again, these places are growing exponentially, so exponentially, just based on sheer survival. So let's go ahead and go back a slide and calculate the doubling time for each one of these populations. And you can go ahead and calculate the doubling time for the ones that apply. Go ahead and pause the video now. So if you went ahead and did that, practice the doubling time calculations, you might have gotten frustrated if you went and tried to calculate the United States. Remember, you can only use formula for doubling time for exponential growth. United States, China, do not apply. Now in India, it would take 43 years for the 1.2 billion people there to double. Japan does not apply, but in Nigeria, at about 28 years, their population will double because they're growing exponentially. We can use that rule of 70. So that's a quick and easy way, and I've seen those questions on the AP exam, all right, in practice exams. You might have to use the rule of 70, and it's all about just quickly plugging in the correct numbers, and I'll go back to the formula. Plugging the correct numbers and making sure you put everything in decimal form. Okay, 0.70 divided by 0.012 if you're doing the world. All right, moving forward. We did a lot of stuff here today. All right, we talked about exponential growth and logistical growth, the J and the S curve. All right, we looked at the age structure pyramid and the percent growth rate and the rule of 70 as being a convenient way to figure out the population and how fast and how quick it doubles. All right, so nice work. What I'm going to do is I'm going to leave you off here, and I'll join you for part 3 next time. So thanks.